Okay, so today we're going to talk about unit conversions. Now, why do we convert? So we convert when we're trying to combine quantities that are measured in different systems. For example, if I said, I want you to combine the following two measurements, 500 seconds walking and 10 and a half minutes driving. How much time was I traveling? Okay. Quantities that need to be relayed in a different unit of measurement so that you can better understand it. If you told me that, if I told you that I lived 2,600,000 inches from school, would you really be able to understand the distance in that? Or would it be easier to just say 41 miles? Okay? So here are the different kinds of units that we would have, obviously, for physics. However, we may be dealing with other items that are not just grams, right? We might be given some other unit in a non-metric system and then asked to change that into grams in order to work with that, okay? We may very well be asking for grams, but maybe I wanted the answer in kilograms, but I was given milligrams, okay? So there's many different units of measurement that we might be converting to and from. And they could be for mass, length, time, temperature, amount of substance, electrical current, or even volume. For temperature, when we're converting, let me show you what we work with here. We have a Celsius thermometer and we have a Kelvin thermometer. They are each used in science. However, they do have different measures for when, for example, water freezes or when water boils, okay? Absolute zero is also a different number when it is in Kelvin versus when it is in Celsius. And what you'll notice is that Kelvin is always positive. Absolute zero for Celsius is at negative 273 degrees. So when you're trying to convert between the units, there is a very simple equation that is K equals C plus 273, or Kelvin equals Celsius plus 273. If you need to solve for Celsius, all you need to do is move the 273 over, and there you have it. As long as you have either Kelvin or Celsius, you can solve for the other. So here is an example. Convert to K if Celsius equals 100 degrees. So we are going to take this equation, put in our Celsius amount that we have, and your total should just be an addition problem, so 373 degrees. Here's another problem where you are asked to convert 400 degrees Kelvin to Celsius. And there is the equation, plug it in, and actually before you do that you have to solve for C, so you'll move that over, then plug it in, and your answer is 127 degrees. Go ahead and try this one and see if you can find the right answer. The answer is 123. Convert to Kelvin, or to Celsius. The answer is 143. All right, so prefixes. Prefixes are what you hear before the measurement. So, for example, if we had grams, you would hear milligrams, centigrams, nanograms, things like that. So we use prefixes when it's for convenience, right? So we use it because it's easier to express something that is very large in number or very, very small. Okay, it does say easier to express very large numbers. However, it is also for very small numbers. So you can add that to the notes here and say very large and very small numbers. For example, if I were to say 1,000 grams equals 1 kilogram, 1 kilogram, I know what 1 kilogram feels like. I know what the mass of 1 kilogram is like. You don't have to tell me 1,000 grams. I can't really wrap my head around that. Instead of 1 million grams, you could say 1 megagram. Instead of saying 0.000000001 gram, which is super tiny, who wants to say all those zeros? Instead, you just have to say 1 nanogram. It's just easier, and you know that when you hear that prefix, it means either something small or maybe something very large. Here are the SI units and the prefixes that we most commonly use. There are the symbols for them, and what you'll notice is there's the base unit here, which has grams, liters, and meters. So this is everything in the first place, in the first place of the order of magnitude for 10 to the 0. Okay, so that's meaning that it's just what it is. Okay, now if you were to go and you were to take this basic unit and you were to say kilogram, then we know that a kilogram is 10 to the 3, which is equivalent to having 1, 2, 3 zeros. Okay, so it's like 1,000. If we went lower, below the base unit, then we would have, like, for example, milli. We would go over here and we would realize that we had an order of magnitude to the 10 to the negative 3, and that is equivalent to 2 zeros in front of the 1. Okay, so it just shows you how, when we were learning the scientific notation, what these terms mean, what the order of magnitude really means. When you go negative, you know it's really small. When it's positive and it's a big number at the top, you know that it is a very large number. So sometimes you might be given centimeters and you are asked to work in kilometers instead, or vice versa. And so let's go ahead and talk about a mnemonic device in order to figure out how to easily convert between metric units. So we can look at this as saying King Henry died by drinking chocolate milk, denoted by K, H, D, B, D, C, M. And notice that these over here are lowercase. They stand for kilo, hecta, hecto, deca. And then these are the basics: gram, meter, liters. Deci, centi, milli. Again, here you have your orders of magnitude at the bottom, just so that way you can kind of keep seeing them and knowing what they mean. Now, we call this the stair-step method. If you were to need to figure out how many milliliters is in 4.9 liters, the first step that you would want to do is to look at the prefix that you have. So we just have liters. There is no prefix. So we know that that is basic. That's in the center. It's 10 to the 0. It just is. Now you want to count how many steps you need to get to the prefix that you want. Okay, so you are wanting to go to the milli over here. So how many steps? 1, 2, and 3. Step 2, you want to move the decimal point in the same direction that many steps. So remember, we moved 3 spaces to the right. So you're going to take your number, take the decimal point, and you're going to move the decimal point 1, 2, and 3. Step 3 says to fill the empty spaces with zeros. And now, remember that your decimal point moved 3 spaces. And so now your new answer is that 4.9 liters is equivalent to 4,900 milliliters. Okay, let's go ahead and have you try. 560 milliliters equals how many kilometers? So step 1 tells you to look at the prefix that you have. We have milli, and milli is all the way over here. We are trying to get to kilo, which is all the way over here on the left. So count how many steps? 2, 3, 4, 5, and 6. So we are moving the decimal point 6 spaces to the left. So if I can't see my decimal point in my number, we know it is always at the end on the right. So that's 1 space, 2, 3, 4, 5, 6, and you put your decimal point there. Fill the empty spaces with zeros, and your new answer is that 560 millimeters is equivalent to 0.00560 kilometers. Okay, go ahead and pause this and try to find the conversion. Okay, so hopefully that made sense. If not, go back and review your TNOTES or even the video itself and see if where you might have made a mistake. Okay, so with dimensional analysis, also known as unit factor method, dimensional analysis is converting units from one system into units of another. So this is used in both math and science, and it is definitely something that we need to know. Again, if you have already watched this from another class, you don't have to take the TNOTES. So if I were asking you how many eggs are in 3 dozen eggs, you would just need to write down 3 dozen eggs, right? And notice that I have this cross right here, so that way you can know that, oh, okay, we know that for every dozen eggs, there are how many eggs in 1 dozen? We know that there are 12 eggs. So notice here, I am going to be canceling the parts that are exactly the same, and all that I am left with is eggs. So you are going to multiply the top stuff and divide by the bottom stuff, and keep the only measurement that is left. So you have 36 eggs. Here's another example. If you were converting from inches to centimeters, let's say we started with 10 centimeters, and we want to convert 10 inches into however many centimeters that is. So first you write down the number and the unit, and therefore, there we go, we put this little cross right here, and we know that our conversion factor for this is 1 inch equals 2.54 centimeters. So if we want to convert to centimeters, it goes on the top, because then the inches will go on the bottom. And then you can cancel, and what you're left with is the centimeters. Your answer is 25.4 centimeters. If you were to go to 25.4 centimeters on the ruler, you would see that 10 inches is on the other side. Okay, so metric conversions. If I were to ask you how many minutes are 720 seconds, okay, you would first want to write down the factors. So we know that there are 60 seconds in every minute. Step 2 is that you're going to write down the given, which is 720 seconds. Put up your little cross, and you are going to now, because you know you need the seconds to cancel, the seconds is going to have to go in the bottom. And then we know that for every 60 seconds, there's 1 minute. Perfect. Now all we need to do is cancel the units and solve. That leaves us with minutes. So everything on the top you multiply, everything on the bottom you divide. So our answer to 2 significant figures from up here is 12 minutes. Let's do another example. How many hours in 6,500 seconds? Let's write down the factors. So now we're going from seconds to hours. We know that 60 seconds is for every minute, and there are 60 minutes in every hour. Write down the given, put up your cross, and because you know you want to cancel the seconds are going to go down at the bottom, and we know for every 60 seconds there is 1 minute. And then you're still trying to get to hour, so in order to cross out the minutes, the 60 minutes has to go at the bottom, and the hour goes on the top. Now you cancel and solve, leaving you with hours, and your new answer to 2 significant figures up here is 1.8 hours. Now, this dimensional analysis can be used in place of the step method. So if you forget about the whole how many spaces to move the decimal point, you can use dimensional analysis. So first, write down the factor of, for example, how many millimeters in 2.6 meters. We know that there is 1,000 millimeters in every meter. So you want to write down the given, which is 2.6 meters. Draw your cross, and because you know you want to cancel the meters, you are going to put the meters on the bottom and the millimeters on top. Cancel and solve, leaving you with millimeters. Do your multiplication and division, and your new answer to 2 significant figures is 2,600 millimeters. Here are some problems for you to try. Go ahead and pause this, and you can do them in various ways. You can either use the step method, or you can use dimensional analysis. Either way, you should probably know how to do it both ways, and you will be expected to know this on the photo. Okay, with this one, you're going to definitely have to use dimensional analysis. The answer is 36.1, which is to 3 significant figures. So we have 14.2 inches times, and notice that my 1 inch is on the bottom, the centimeters are on top. That gives me 36.068, and your total answer at the end should be 36.1 centimeters. Okay, so for a more complex conversion, let's try kilometers per hour to meters squared. So we will need to convert kilometers per hour into meters squared, and we can do this by doing both conversions at once using the same method as in the previous conversion. So step 1 is to write down the number in the unit, which is 80 kilometers per hour. And we are going to convert the time first. So let's focus on the time, and we know that 1 hour is 60 minutes and that 1 minute is 60 seconds. So 1 hour, we want them to cross out, and 1 hour is equivalent to 60 minutes, and 1 minute is equivalent to 60 seconds. Okay? Now, in order to convert the distance from kilometers to meters, let's go ahead and make sure we put down our minutes, right? And now we know we have our hours, our minutes per second, and now we know that 1,000 meters is equivalent to 1 kilometer. So we go ahead and put that there, and we put the kilometers at the bottom so that way they can cancel out. So now we cross everything out, cancel, 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 and the only things left is the meters per second. So your total is 80,000 meters divided by 3,600 seconds. And now all you have to do is the math. So your total is 22 meters over seconds. All right, so pretty much what you can tell is 80 kilometers per hour and 22 meters per second are both velocities. The car that is moving at a velocity of 80 kilometers per hour is traveling the exact same velocity as a car that is traveling at 22 meters per second. So it's just a different way to represent the same thing. Okay, so be ready to use these notes in class.